Hey everyone, welcome back. Today we're going to look at linear function forms. If you've completed the previous videos, grade 9 graphing videos and the grade 10 slope video, then today's lesson will be a lot easier for you. So there are three main forms of linear functions. We have y equals mx plus b, slope-intercept form, ax plus by equals c, this is standard form, and then y minus y1 equals m times x minus x1, point slope form. And each of them have their advantages, so we're going to cover all three of them right now. So let's start with slope-intercept form. So we have y equals mx plus b, and so an advantage here is that the slope is given. M is our slope. The y-intercept is given, that's b here, and it's easy to graph. So here we have our linear function here. When it crosses the y-axis here, b, this is our y-intercept. And so when x is 0, we get our y-intercept b, right? If we plug in, m times 0 is 0, 0 plus b is b. So when x is 0, y is b. So that's our y-intercept. And m is our slope. We covered that already, right? Change in y over change in x. This is the steepness of the function, like that. So example 1, graph the following functions. So here we have our first function here, y equals 2x minus 3. We notice that the slope is 2 over 1. And we also notice that the y-intercept is negative 3. So we start at negative 3, right? 1, 2, 3 like this. And now we're going to go over by 1, that's change in x. Up by 2, that's our change in y. Over by 1, up by 2. Connect the dots like that, and there is the graph of our function. Okay, let's do another example. So b, y equals negative 2 over 3x plus 5. So we start at our y-intercept of 5 right here. We're going down by 2, 1, 2, and over by 3, 1, 2, 3. Down by 2, over by 3, connect the dots. There is the graph of our function. So practice number 1, graph the following functions, a and b. Go ahead and pause the video and answer that. Okay, we're back. So we're starting at 1. The slope is negative 1 over 1, so we go down 1 over 1, down 1 over 1. Connect like that, and so there's the graph of our function. b, we're starting at negative 1 is our y-intercept. Up by 3, 1, 2, 3, and over by 4, 1, 2, 3, 4. Connect those dots, and there's the graph of our function. Be sure to label the axis and write down the function beside the graph like that. And write down the couple key points. You notice I wrote down negative 1, 2, and 4 like that. These are the key values that we need to know for this graph. Okay, example 2. Find the equation of the linear lines passing through the 2 points. So here's our 2 given points like that. First thing we're going to do is find the slope between these 2 points. So delta y over delta x. So y2 minus y1 equals x over x2 minus x1 like that. So 9 minus 5 over 6 minus 4 like that, which gives 2. So we know that the equation is going to be y equals 2x plus some b, right? We know that m is 2, so we update our equation like that. And so to find b, we plug in a point on the line. And so let's take 4, 5 because it's smaller. So we plug in x equals 4 and y equals 5. We do the algebra and we get b equals negative 3. And so that is the equation of our line, y equals 2x minus 3, like that. Okay, b, let's do another example. So we have 3, 3 and 6, 4. So first we're going to do the slope between the 2 points. So 4 minus 3, 1 over 6 minus 3, 3. So we know that our equation is going to be of this form, y equals 1 over 3x plus b, like that. So we need to find our b value, so we plug in one of the points into our equation here, and so we get b equals 2. And so now we update our equation here, y equals a third x plus 2. This is the equation of our line passing through these 2 points. So time for some practice. Practice number 2. Find the equation of the lines passing through the two given points. So A and B. Go ahead and pause the video and answer that. Okay, we're back. So A, slope, y2 minus y1, so 5 minus 2. And then x2 minus x1 is 2 minus 1 like that. And so we get a slope of 3. So our y here is going to be 3x plus b. Now we need to find our b value. So we're going to plug in one of the points. Whichever one you plug in is no problem. You just take what it was easiest is what I recommend. So 1, 2 is the smaller value, so that's easy. So x equals 1, y equals 2, and then we get b equals negative 1. And so there's the equation of our line, y equals 3x minus 1. Okay, in b, our slope here is going to be, oh, there you go, 2 minus 3, like that, over 8 minus 4. And so this gives us a slope of negative 1/4, like that. So we update our equation, y equals negative 1/4 x plus b. We're going to take 4, 3, plug it into our equation. We get b equals 4. And so this is the equation of our line, y equals negative 1/4x plus 4, like that. Okay, standard form. So this is where we have ax plus by equals c. And typically a, b, and c are integers. And if you're writing something in standard form, you want to have a being positive, greater or equal to 0. So what are some of the advantages here? These standard form equation is easy to graph using intercepts. And we use standard form a lot when we're solving linear systems. And we're going to do linear systems in the next chapter. So example 3, graph the following functions. So here we have 2x plus y equals 4. So we've covered this before in grade 9, right? So if x is 0, we plug that in and we get y equals 4. And if y is 0, we plug that in, then we get 2x equals 4. And so x equals 2. So we have 0, 4, which is right there. And then we have 2, 0, which is right there. And then we connect the two dots like that. And so there's the graph of our function. B, negative 3x plus 2y equals 6. So we plug in x equals 0. So what's left is 2y equals 6. And so y equals 3. We're also going to plug in y equals 0 like that. And so what's left is negative 3x equals 6. And so x is negative 2. So negative 2, 0 and 0, 3 are our 2 points, and then we connect just like that. So time for some practice. Graph the following functions, a and b. Go ahead and pause the video and answer that. Okay, we're back. So a, 3x plus 4y equals 12. We'll start with x equals 0. Plug that in. We get 4y equals 12. Y equals 3. And then we're going to plug in y equals 0. And then we get 3x equals 12, which makes x equal 4. So we have 0, 3 here and 4, 0 here. And then we connect, and there's the graph of our function. So we're using the y-intercept and the x-intercept to graph our linear function. B, negative x plus 5y equals 10. So we'll start with x equals 0, plug that in. We get 5y equals 10, and so y equals 2. And then we're going to plug in y equals 0 right there. So we get negative x equals 10, and so x equals negative 10. So here we have 2, 4, 6, 8, 10 like that. So this is actually a negative 10, like this. And then this is a 2, like that. And so we connect the two dots as such. Okay, point slope form. So this is y minus y1 equals m times x minus x1. And so here's some of the advantages. One, the slope is given. So that's our m value that's given here. And what's given is a point on the line. This x1, y1 is a point that is on the line. And then you can graph easily using this point and the slope. So that's what we're going to do here. Example 4, we're going to graph the following functions like that. Okay, so let's start like this. So there's our equation. And we notice that the point that is on the line is 2, 5, like that. All right, so that's the point that is on the line, 2, 5. And then the slope that is given is right here, -3/2. So when we're graphing, we go to the point 2, 5. There's our point that is on the line. And then we can just continue our slope. So slope here is going down 3, right? -3 is delta y, so we're going down by 3, and then 2 is change in x over 2. So we're going down 3 over 2, down 3 over 2 from that point that we know is on the line. And then we connect as such, and there's the graph of our line. If you want, you can write the equation beside. I just forgot to do that there. You can ask your teacher if that's something that's mandatory or not when you're doing graphs. So B. Y plus 1 equals 2 times x plus 3. So I'm just rewriting it differently here. Y minus -1 and then 2x minus -3. And I wrote it like that because then you can see that the point is -3 and -1 like that. So that's the point that is on the line. And then the slope is 2. That's given to us. So we're going to start at this point, -3, 1, 2, 3, like that, down 1. So that's our point on the line. And then we're going to draw our slope according to that point. So we're going to go over 1, up 2, over 1, up 2, right? So slope is 2 over 1, right? That's our slope, over 1, up 2. And then we connect the lines, connect the dots like that, and that is the line of our function. Okay, practice number 4. Graph the following functions. So we got A and B here. Go ahead and pause the video and graph that. Okay, we're back. So A, we see that the point is 1, 2, and the slope is 1 over 3, like that. So we're going to start at 1, 2, so 1, 2 like this. 1 over 3, so up 1 over 3, up 1 over 3, like that. So we identify the important numbers, and then we draw the line of our function. And so this is the graph of our function. Okay, B. Y minus 4 equals -1/2 x minus 1. So the point on the graph is 1, 4, like that. The slope is -1 over 2. So we're going to start at our point, 1, 4, so 1, 4, like that. Down 1 over 2, down 1 over 2, down 1 over 2, like that. And we connect the dots as such. And so there is the graph of our function. Okay, example 5. We have a couple of special cases here that we're going to cover. And so graph the following equations. So when we have this here, x equals 2, we can think of it as x equals 2 plus 0y. And so no matter what y value you plug in, the x value is always 2. And so here x is 2. And so for all the different y values, x is always 2. So x equals 2 is a vertical line like that. Okay, so B, x equals -4. So we go to -4, and no matter what y value you plug in, the x is always -4. So x equals -4 is a vertical line like that. Okay, C, y equals 3. So we go to y equals 3, and we can think of it as plus 0x. And so no matter what x value you plug in, y is always 3, like that. Okay, and D, here's another one, y equals -1. So no matter what x value you plug in, the y value is always -1. Okay, so practice number 5, A, B, C, D, graph the following equations. Go ahead and pause the video and answer that. Okay, we're back. So x equals 3. So we go to 3 and there's our x equals 3. B, x equals -1. So we go to -1. There's our x equals -1, like that. C, y equals 1. So there's our y equals 1 here. And y equals 0, it's in red on top of the x-axis, like that. That is our y equals 0 equation. Okay, we're going to practice a skill now that you're going to use later. And so the practice number 6, rewrite the following equations in standard form, right? So that's the ax plus by equals c. And I want you to write your answers with a being greater or equal to 0. Okay, so go ahead and pause the video and answer that. Okay, so hopefully you practiced that. We're going to be using this in a later video. And so so y equals 2x minus 3. So we're going to put the y on the right-hand side. So we have 2x minus y, and then 3 goes over to plus 3 like that. So there we have it. 2x minus y equals 3. B, we're going to go times 3 to both sides like that. And so this gives us 3y equals negative 2x plus 15. We're going to go plus 2x so that it's on the left-hand side. So 2x plus 3y equals 15. Right? And so a, b, c need to be integers, and our a here is greater or equal to 0. Okay, so c, 2y equals 3x plus 6. So bring the 2y over to the right. So 3x minus 2y equals -6. And so there is our standard form. Okay, D, y minus 6 equals 2 times x plus 3. So we're going to distribute the 2 like that. So 2x plus 6. We're going to bring the y onto the right-hand side. So minus y to both sides. So 2x minus y. And then we're going to go minus 6 to both sides. So minus 12 equals 2x minus y as such. E, y plus 2 equals -3 times x minus 5. We're going to distribute the negative like that, so minus 3x plus 15. And so we're going to bring the x onto the left-hand side, so 3x plus y, and then we're going to move the 2 onto the right-hand side, so 15 minus 2 equals 13, like that. F, so we have a 5 over 7 here, so we're going to go times 7 to both sides. And then we're going to distribute that 7 here. So 7y minus 7 like that equals 5x minus 10 as such. And then now we're going to go minus 7y to both sides. So we got 5x minus 7y. We're going to go plus 10 to both sides to bring the 10 over here. And so that's our answer here. 5x minus 7y equals 3. And that's it. It's that simple. I'll see you guys in the next video.